All right, welcome back. Now we're going to be working 18 through, I guess, about 2022 here. And so we have a problem here on 18, and it cut off on my page, so I'll just read it. It says, a civil engineer must design a wheelchair ramp that is accessible next to a set of steps leading to a building. The height from the ground to the top of the stairs is 2 feet based on ADA codes. The slope must be 112, and that's code. Slope is equal to the rise and run of the ramp. Okay, so it says sketch that stuff. All right, so let's get us a little ramp going here, an incline plane, something like that. That's going to be a right angle. And we have 2 feet here. So remember, 2 feet. That's how far we need to go up. So 2. So that's going to be my distance resistance, just in case you were curious. And then on an inclined plane, this slope here is going to be my distance effort. Or slope, okay? And then we have also the run would be this down here. So the next question says, using the ADA code, remember that's 1/12, okay? What's the allowable minimum length of the ramp base, okay? Well, if you think about, so it's asking me to solve for this distance here. So remember, it's got to go, I can only go up 1/12 feet. So our formula is going to be the slope is equal to the rise over the run. And if you think about my rise is 2 feet, well, what's my run? It's 1/12 because that's my code, okay? So if I plug that in my calculator and I said 2 divided by 1 divided by 12, that should give me 24, and it does. 24 feet, okay? So now I can keep cruising here, and I can say, okay, well, I could label that. I could go back and label that real quick, so I will. We know we got to have at least 24 feet. Using the known height and calculated base length, what is the length of the slope of the ramp? Okay, well, we got to find that, so we're going to use old Pythag. A squared plus B squared equals C squared. And so I'll put this in my calculator, and like this, I'll say square root of 24 squared plus 2 squared is going to give me the distance effort in this case. So let's do that. Second here, 24 squared plus 2 squared. And it gives me 24, we'll round that up, 0.1 feet. Okay. Now, so if I wanted to come back up here and label that, I could say 24.1 feet. Now, what is the ideal mechanical advantage of the ramp? IMA is equal to distance effort over distance resistance. And I look at this and I go, well, what's my distance effort? 24.1 feet. What's my distance resistance? 2 feet. So that gives you 12.042 feet is your IMA. All right, next it says if a person in a wheelchair have a combined weight of 185 pounds, how much ideal force is required to travel up the ramp? Well, what did they just give you? The person, that's going to be your force resistance. So this is FR, okay? So remember, we can set IMA equal to AMA and solve for this. So we're going to say IMA is equal to AMA. And if I really thought about that, IMA, remember, is ideally I'm going to kill a deer. So DE over DR is equal to FR over FE. So if I think about all those things, I can set, okay, distance effort. Well, we knew that was 24.1. Distance resistance, 2. What is our force resistance? 185 pounds. I guess I should put my feet there. Okay, so this is my X, okay? So come over here and I'm going to, 2 times 185 equals, divided by 24.1 equals. So my force effort is 15.35 pounds. And I hope that helps.